This video is meant for Mrs. Rose's AP Calculus class, and in it we're going to do the third free response question from our derivatives AP packet. Okay, and it's falling from a rectangular box, so I'm going to draw my rectangular box that is filled with sand, and the base measures 40 by 20 and has a height, and sand is falling out at 100 cubic inches per minute. How is the depth of the sand in the box changing? Well, first we're going to need the volume of the box equation. So volume is going to be length times width times height, and the length is going to be 40, the width is going to be 20, and the height is unknown. And we know that the volume is going to be 800h, because of course 40 and 20 aren't changing. To figure out the depth in the box, the related rates, we need to take the derivative of this equation. So we're going to have the derivative of v and the derivative of h with respect to time. dv dt equals 800 dh dt. This derivative is worth 1 point. Then we get 1 point for plugging in negative 100 for dv dt. It's negative because the sand is falling out of the box, and equals 800 dh dt. And then of course when you divide both sides by 800, you're going to get negative 1/8 equals dh dt. So our concluding sentence is the depth of the sand is decreasing at 1/8 inches per minute, or inch per minute. It's decreasing because it's negative, and we get 1 point for our conclusion. For part B, the sand is forming a conical pile below. So we have our conical pile, and at a particular moment the pile is 23 inches high and the diameter is 16 inches. So, and we also know the diameter of the base is increasing at 1.5 inches per minute. So how fast is the area of the circular base of the cone increasing? So we know that the area of a circle is pi r squared, and then we also know that the diameter is 8, which means the radius, the diameter is 16, which means the radius is 8, and we know that the rate of change, the derivative of the diameter is 1.5, so half of that for the radius is 0.75. When you take the derivative of the area, you take it with respect to time. So dA dt equals 2 pi r dr dt, and that derivative is worth a point. When you plug in your radius and you plug in your dr dt, that equals 12 pi, and that is your rate in which the area of the circular base of the cone is changing or increasing, and that is worth 1 point. For part 2, we're using the volume formula for a cone, and we know that dv dt is positive 100 because of course the sand is falling onto the cone right now versus emptying. We know that the radius is 8, we know that the height is 23, we know that dr dt is 3/4, and we don't know what the dh dt is. So we're going to take the derivative of the volume, and we have to use product rule, so we're going to have the derivative of r squared, which is 2r dr dt times h, plus r squared times the derivative of h, and that is worth 2 points. 100, and plugging everything in, and then going ahead and solving. dH dt is going to go a really weird looking number, and that's in inches per minute, and that answer is worth 1 point. Finally, for this problem, you get 1 point for correct units throughout. And that's the 9 points for this FRQ.